Let me do a few more problems for you in terms of, this is what we call stoichiometry. I realize this is one of the most difficult topics for the class, so I wanted to do a few more problems for you. So I've written some out. Okay, so let's look at this first one here. How many moles of oxygen are needed to produce 3.5 moles of water? So when the problem gives you just one number, unit, and a substance, you'll find in a second here that makes them a little easier. So you always start with your given, 3.5 moles water. And then I've got my balanced equation, and I'm going to use this equation for the next couple of problems. So my balanced equation has, again, numbers in front, and if there's no number, you assume it's a 1. And if you remember just from the presentation I just gave, these numbers can use the units moles. They are not grams. I can't say that enough. Not grams, but they are moles or individual molecules or atoms. So I have, in other words, 2 moles of hydrogen plus 1 mole of oxygen will make 2 moles of water. Okay, now knowing that, I can convert out of what I don't want moles of water, and into what I do want. The question asks for moles of oxygen. So that when I'm all done, I have an answer in terms of moles of O2, oxygen. This, remember, is oxygen. It's diatomic, so when I say oxygen, I really mean O2, if it's in its elemental state or by itself. Okay, now, these numbers here, where do I get these numbers? Well, that's what's in front of them on the balanced equation. There's the invisible 1 that's assumed in front of oxygen, and there's a 2 in front of water. It's a 1-to-2 ratio. Now, what about the hydrogen? What about this guy right here? Well, of course, it's needed for the reaction, but this question isn't asking about it. It would be like, think about a recipe. If you had a recipe for making chocolate chip cookies, and you had the whole recipe card, but I said, how many sticks of butter do I need to make, 3 dozen cookies? That doesn't mean you don't need all the other ingredients. It's just that my question is limited to the one ingredient and the product. So just because it's not questioned or not listed in the question doesn't mean it's not there. It's just the question. This question doesn't care about it. Okay, moles of water on top, moles of water on bottom, that cancels. So multiply if it's across the top, divide if it's on the bottom. So 3.5 divided by 2, do you know what that is? 1.75. So I need 1.75 moles of oxygen to produce 3.5 moles of water. So anytime you're going mole to mole, you use the balanced equation, BE, balanced equation. Okay. Now let's look at this next one. We'll call this question number 2. How many grams of oxygen are needed to produce 10 grams of water? Well, as I said, the numbers in the balanced equation, those are not grams. They are moles or individual molecules. And so obviously that makes this problem a little more difficult than the last one. I'm given grams of oxygen, and I'm looking for grams, I'm given grams of water, 10 grams of water to be exact. I'm given grams of water, and I'm looking for grams of oxygen. Since the numbers in the balanced equation are not in grams, that means this is not going to be achievable in one step. Okay? But instead, let's think about a pathway. So, to be able to convert between water and oxygen, like I did up here, I use the balanced equation. But the balanced equation is in moles, not in grams. So I'm going to have to, step 1, go from grams of water to moles of water to be able to then use the balanced equation, step 2, and convert from moles of water to moles of oxygen. And that, as I just said, uses the balanced equation. I'll come back to that first one in just a second. And then finally, once I have moles of oxygen, I don't want moles with my oxygen. I want grams of oxygen. So step 3, I'll convert moles to grams of oxygen. So again, this is so important, you guys. The only way to change your substance when you're given information about one substance and I'm asking for information about another, the only way to change your substance is to use the balanced equation, because that's how they're related. And if you start with moles and end in moles, like in this one, well, easy, you use the balanced equation one step and you're done. But when I'm talking about mass, well, then that throws in an extra step. So that's where steps 1 and step 3 come into play. So let's think about how can we go from grams of water to moles of water. Grams to moles, moles to grams, either direction. Molar mass. Molar mass. Remember, molar mass of a substance is the mass of 1 mole of that substance. So obviously for water, it's going to be different than oxygen. For water, the molar mass of water, when you add it up off the periodic table, it's 18 grams per mole. For oxygen, 2 O's from the periodic table, well, each oxygen is 16. Whoops. So 16 times 2, O2 has a molar mass of 32 grams per mole. So those are going to be what I need in step 1 and step 3. And step 2, I said I'm going to use the balanced equation. Balanced equation shows a 2 mole water to 1 mole oxygen ratio. And so this over here is what I'm going to use as my conversions. But obviously it's going to be 3 steps. That makes this a little trickier. So I'm going to start with my given, 10 grams of water. And I said step 1, I'm going to go from grams of water, so put that on bottom, into moles of water, put that on top. So that grams of water cancels when I'm done here in a second. Step 2, I'm going from moles of water to moles of oxygen. So put moles of water on bottom so it cancels. Moles of oxygen, what I want at the end of step 2, on top. Oops. And then step 3, I'm going from moles of O2 to grams of O2. So I put that on top and bottom. And everything should cancel. And you notice I set this all up before I even plug my numbers in. Keeps things a little cleaner. Everything should cancel except the unit I want and the substance. I want grams of oxygen. Okay, now I'm ready to put my numbers in, and that's where this stuff's going to come in. So 1 mole of water has a molar mass of 18 grams. Again, in other words, 1 mole of water weighs 18 grams. Moles of oxygen to moles of hydrogen, it's a 2-to-1 ratio. There's a 1 in front of O2 right here on the balanced equation. There's a 2 in front of water. And then finally, moles to grams of oxygen. 1 mole weighs 32 grams. I'll let you do the math here on your own. Remember, if it's across the top, it gets multiplied. If it's on the bottom, it gets divided. So I would do that as 10 times 32 divided by 18 and then divided by 2. It's going to be close to 10. See what you get. Okay, let's go on to the next slide then. All right, you guys, sorry, I gotta start this one again. Okay, so when you have 3 moles of hydrogen and 3 moles of oxygen, and what's my balanced equation? And each sandwich gets 2 slices of bread, 2 slices of meat, and 1 slice of cheese. Okay. And let's say you go in your kitchen and you find out you have 10 slices of bread and you have 5 slices meat and you have 3 slices cheese. And you want to make as many sandwiches as possible based on this, but to be able to make a sandwich, you've got to have all these ingredients in those quantities. Okay, so for each one, you can figure out how many sandwiches you can make, right? If I have 10 slices of bread and it takes 2 slices of bread per sandwich, I can make 5 sandwiches just based on my bread. For meat, well, that's not as good. Every sandwich needs 2 slices, and I'm not making half sandwiches, so I'm only going to be able to make 2 whole sandwiches based on my meat. Okay. 2 times 2 is 4. I'm going to need 4 slices, but I'll have extra. That's fine. I said you have to make whole sandwiches. And then finally, last but not least, let's look at it for the cheese. Each sandwich takes 1 slice. If I have 3 slices, I can make 3 sandwiches. Okay, so for each ingredient, I just worked out how much product I can make. So these are my reactants. This is my product. And I just kind of did it. Hopefully you guys can see that. It's pretty simple math. And if I can only make whole sandwiches, in this particular example, I can only make the lesser of the numbers. So I only have enough ingredients, reactants, to make 2 sandwiches, to make 2 complete sandwiches. Yeah, I know I've got extra cheese, and yeah, I know I've got extra bread, but that's all I have got for meat. So the max I can make, 2 sandwiches. Whoops. That's all I can make, 2 sandwiches. But I'm going to have some leftover of everything, but that's just the way life works. We would say then that the meat is my limiting reactant. It's the reactant that limited me to that smaller amount. I had excess bread, I had excess cheese. In fact, if I'm only making 2 sandwiches, I'm going to have 1 slice of cheese left over. And again, if I'm only making 2 sandwiches, 2 times 2 is 4, I'm going to have 6 slices of bread left over. And in fact, since I don't have enough meat, but normally you'd use up all your limiting reactant. Do you see how I figured out how much excess I'd have? All right, so that's an everyday example, and I'm guessing hopefully that made lots of sense to you. But let's take it to a chemistry example, okay? And let's look at this problem right here, and this is what I'll leave you with for today. If you react 3 moles of hydrogen with 3 moles of oxygen, oh, and I should say we're still using the water balanced equation. It's a pretty simple one, and they all work the same conceptually. Okay, so if I have 3 moles of hydrogen, there's a number, unit, and quantity, reacting with 3 moles of O2, how much water will be produced, which reactant is limiting, and what's left over? Okay, so when you have these limiting reactant problems, okay, so when you have these quantities and we're looking for water, so what you have to do when you have 2 givens, as I like to say, 3 moles hydrogen, and I have 3 moles oxygen. We have to determine, just like we did for the bread and the meat and the cheese, how much product I can make based on each ingredient. So I'm going to figure out how much hydrogen will give me how much water, because I'm looking for moles of water. This is what happens when you do these late at night, you guys. And then the same thing for oxygen. I want to figure out, based on my oxygen, how much product, which is water, how much can I make? Top and bottom cancel, moles, water. Then I go to my balanced equation. Remember, converting between moles and moles. There's a 2 in front of H2, there's a 2 in front of water. So based on my hydrogen reactant, I can make 3 moles of water product. And that's all well and good, but it doesn't really tell me anything until I do it for the other reactant as well. So again, conversions, when I'm changing substance, it comes from my balanced equation numbers. There's an invisible assumed 1 in front of O2. There's a 2 in front of water. 3 times 2 is 6. Now again, just keep thinking back to the bread exercise we just did. You can only make the lesser of the 2. So I'm only going to be able to make 3 moles of water. So that's this answer here. How much water can be made? 3 moles. Had the question asked how many grams that was, you could take it a step further into grams of water. Remember, moles to grams, grams to moles, using the molar mass. 1 mole of water weighs 18 grams. So you could use that and figure out grams if you needed to. This question wasn't specific, so hey, I'm going to just leave it in moles. Okay, which reactant is limiting? Well, that's the reactant that limited me to that lesser amount. So it's always limiting reactant, not product, limiting reactant. Which reactant limited me to the smaller amount? The hydrogen. And then finally, what's going to be left over? Well, I'm going to have oxygen left over. I'm going to use all this up. All the hydrogen's going to be used up to make my 3 moles of water. But I'm going to have excess oxygen because I'm not making 6 moles of water. I'm only making 3 moles of water. And in fact, if I had to figure it out, I could now work backwards and figure out how much oxygen I'm actually going to use. And you might even be able to just look at this and tell, but let's work it all out. How much oxygen are we actually using? Well, we're only going to make 3 moles of water. Balanced equation again allows me to convert from moles of one thing into moles of another. So 3 moles of water divided by the 2 is 1.5 moles of oxygen. So I'm only using 1/2. So 3 minus 1.5, I'll have 1.5 moles, just happens to be cut in half in this time. I'll have 1.5 moles of oxygen in excess. And again, if the problem had asked me how many grams of excess, well, I could go moles to grams for this substance using its molar mass. And as I found on the last slide, molar mass of oxygen of O2, 1 mole weighs 32 grams. So if I have 1.5 moles, 1.5 times 32, I don't know, whatever that is, that would be your grams of oxygen in excess. Okay, I hope this helps everybody with these stoichiometry problems. If not, I highly recommend you also check out Chem Guy, the link I've got in the class for Chem Guy videos. I actually have to...